I will start with the non-important stuff. So about me, I'm a software developer in IT industry for more than 20 years. I discovered DevOps recently. I'm a community organizer. I work as an SRE for 5 years with breaks. I'm programmer for 30 years, and I'm introvert for 40 plus years. And I'm also DevOps trainer for 3+ months because I was doing a training for a local company in Czech. So that's me. The agenda will be, there will be just a slight touch of Terraform, but the presentation is not about Terraform. Sorry for that. It's more about GitHub Action, and I will explain you why. So we start with a GitHub Action, and then we talk about how to integrate Terraform with GitHub Action, and then some tips and tricks about deployment strategies and other stuff. So first quiz, relax your hands because we'll be raising hands. So this is like on which phase or which schema of this pyramid are you in about Terraform? So who doesn't know that he doesn't know? So that one. One, okay. Who knows that he doesn't know, or she? Okay, that's good. Who knows that he knows? Okay, that's good. And who doesn't know that he knows? So I'm somewhere here between green and blue. So for me, it's difficult to explain what Terraform is because I'm using it for a long time and I take everything like automatic. So the second thing is that this is the chart when you have competence on the X chart and how this works, and the confidence on the Y axis. So when you start learning something, you think you know about it, everything. So if you think that you don't know, that you are probably somewhere here or here. But most people that heard about something, they are usually somewhere here. So it's the average. So who? Maybe let's retry the exercise. Who is the expert of anything he works on? It's not about Terraform. Nobody?
Well, is it what I think or what others think?
What do you think? So these people are here, so they have like high confidence, but they deserve it. So, but there are a lot of people that have low confidence. Oh, sorry. But they have like more knowledge than they think they have. And then there are a lot of people who know about everything, mostly on Facebook and Twitter, and so there's online discussion. They are somewhere here. Okay, so now GitHub Action. GitHub Action started as a workflow engine to automate developer tasks. It was based on what GitHub was initially designed to host open source public repositories and code and applications. There were a lot of actions that were possible to automate with third-party platforms like Jenkins and others, but they decided to start their own, and they create a model that is driven by events. And these events are about what usually you want. You want some contributors, so you want to say hello. If there is some comment, you need to do some action with that. If there is an issue, a problem in the product that you are developing, you need to have some reaction. And then, of course, if there is a pull request created and merged, you need to do something with it. The benefits is that it's embedded with the GitHub repository. And the drawback is that it's declarative and have security limitations. Who is using GitHub Action right now or has some experience? Okay, who thinks he or she is expert on GitHub Action? Okay, I'm the same, so that's why I choose this topic. So GitHub Action workflow is written in YAML. It's usually located in the folder .github/workflows. It can be triggered manually, but mostly it's run by automated triggers or events. There are different workflow types. Something which is more advanced is composite action and reusable workflows. Most of the GitHub action that you will be using are reusable, but it's written by somebody else. And there are also runners. Runners are important for the security. Most of people, they use GitHub hosted runners. But if you are really paranoid about security, you should use self-hosted. The workflow structure is that you have name of the workflow. You have the on clause, which says which event the workflow is designed for, and then you have one or more jobs that are containing the tasks that are processed by the workflow. So this is the simple illustration, which is not very visible, and there are the two runners where you can have two jobs run in parallel, because the jobs are run in parallel unless you specify otherwise. So job is the basic piece of the workflow. There can be multiple jobs. There are some limitations. For example, environment, which I will talk later. There are some simple stuff. The most important is the bold one. So the name of the job, where it runs, which are the self-hosted runner or the GitHub hosted runner. And the most important are steps or tasks which will be done. The step is similar notation, is going deep into the tree. So there are two options. You can use either some third-party or reusable workflow, which you wrote by your own, or you can do run a bash command or something, or you can use a third-party, which is GitHub script, and then you can write your code in the JavaScript or TypeScript. Then what is important are context. I didn't tell you how to design the GitHub action, but imagine I did. Then you have the code, and now you need to pass some data to it. So this is the way how to pass the data. You can have something called variables, and variables are separated by context. Context are important because it tells you where the variable is, and there are a lot of predefined context which helps you to get the data from either repository or the action or your own, or from previous jobs, like the job here, or jobs. So the most important part of this is variables and secrets. Variables and secrets are on the repository level. You can put mainly, because this presentation should be about Terraform, the way how Terraform is authenticated with the cloud providers and other stuff. You can use it for anything, but the main difference is that secrets are encrypted. So if you put secret in there, you can be very sure that nobody can access this if you don't give them access to write the secret out in the workflow. So it's partly like secret, but it depends on who is using it. Then the problem is if you have multiple environments and you want to have different settings for each one, then you can use grouping or nesting. Grouping is using the environment where you can have dev, test, staging, production, and you can have different set of variables and secrets in there. Or you can use nesting, which is kind of dirty, but it's easier. And you can use JSON as a format to store it in separate variables or secrets where you have all the data you need. So this is the example of the nesting. As I said, it's dirty. Can everybody see it? Can somebody explain what this is doing? Some expert on Bash, maybe. So while you are reading it, this is the content of the variable. And this is the way how Bash is kind of gluing it together. So it's reading the nested values from the secrets, which is the context. This can be either the general secrets or it's based on the environment which is selected by the job. And then it's echoing this variable. And then by JQ, is there somebody who knows JQ in this group? Okay, so by JQ and the closest two entries, it's kind of converting to separate rows when it's saying var1 equals value 1, var2 equals value 2, and then it's piping it to GitHub env, which is a file or pipe, and the result is magically it will create var1 and var2, which will be available for follow-up steps in that. So this is kind of tricky thing. I hope you will never need to use it. So reusable workflows are also magical things when you have multiple environments and you want to pass secrets and you are using nesting. Reusable workflow is basically that you have one workflow which is calling another. So this is the code the YAML code of the calling YAML, who is calling the other, which is called callee. I hope this is proper English. I'm not native speaker. And it passes some variables or inputs, and it's passing some secrets. The secrets are hidden, so if you're writing them out in the log, it will mask them with stars or something. This is the way how to mask them. And then you need to define the header, which correspond with the way how it's called, or the vice versa. And then you have the jobs as usual. So there is an example of a simple workflow that you will use for Terraform. There will be always these two steps. This version may differ because this is being incremented by bug fixing. Same here. This version also may be different. If you are using OpenTofu, I recommend you 1.5.7 because this still has to compatible with OpenTofu. Not the information you ever need, hopefully. And this part is kind of cloning or checking out the code from the repository into the runner space, into the disk of the runner. And this is installing the Terraform, so you can use it in the later step. And now we can talk about Terraform. Are there any questions to GitHub Actions so far? Yes?
You said that being decorative is a drawback.
I was assuming that everyone here is a kind of developer and they like Pulumi, so I took it as a drawback. But it's subjective. So what is Terraform? I think everybody knows what is Terraform. Is there somebody who doesn't know Terraform, what it is? Okay. So I usually put this so you know at least what we are talking about. It's an infrastructure as a code tool. Code is something that you store in the repository, and the most important stuff, you can version it. So you can take the infrastructure as a piece of software, which was mentioned on the previous presentation, and you have a kind of tracking or auditing of all the changes in the repository. And it's good for kind of debugging. And it's a code which you can build and you can change. And what it does, it will take the code and it will convert it into the infrastructure in the cloud or on-prem resources. It can be used for anything. There are more like interesting stuff which when you switch to the infrastructure or architecture of Terraform. So Terraform is kind of composition like Lego. And the most important stuff, which will be something you will hate based on which cloud is the provider and provisioners. So it's using the same, Pulumi is using the same. So there are providers, which is kind of third-party code, which is connected to the core, the kernel of the platform. But you can develop this separately from this. So this is just telling what is the standard language. And this is just wrapping the API of the cloud. And then you can use any provider, cloud provider, which you have the Terraform provider for. Here is the developer. It doesn't look like me. And here are the Terraform files. Terraform itself is taking these files and calculating dependency tree, and then doing the stuff automatically or automagically. Okay, so what is important is the state file, which is here in the picture. So when the Terraform is actually applying the change, it will capture all the kind of export or templates or JSONs of the resources that were created, and it will store it as a cache. And next time it will use it to compare what was changed from the previous one. It was like, as you remember on the previous presentation, it says that Terraform appeared from 2014. Before there was a tool called Ansible and doesn't have state file. It still does. It didn't have state file. It still doesn't have. But every time it runs, it takes a lot of time, like minutes or hours, to calculate what is actually in the production. So with the state file, it's much faster. But now we take it for granted. There are some security issues because it also contains all the secret values. It should be protected. So not everybody should have access to the state file. It also should not be deleted, because it will, if you lose the state file, you lose basically the production or the infrastructure. And there are locking mechanisms, so you can have only one run at a time. So now, as you remember, GitHub Action is a workflow engine. So I'm trying to match the workflow with the Terraform workflow. There are several steps which you can implement. You can have some validating on the pull request when you create it, or on the commit when you push a commit to a branch. And it might be checking of the formatting, initialization, and validating if the code is valid. And then once you switch to the plan, you are still not doing the changes, but you are actually looking at the Terraform state. You are looking on the cloud provider or whatever providers you have, and you are looking at the code, and it's comparing these three sources of data, and then it's generating the plan, which is another kind of JSON file, which contains, or binary file, which contains what will be changed or how. And then you say Terraform apply, and it's now doing the stuff which was prepared during the plan phase. So if you will have any kind of GitHub Action workflow that you probably implement all of these steps, some of them are not mandatory, like formatting and validating, but it helps you to reduce the pain when there is a problem. So it will tell you, here is a problem with formatting, which will not break here. But here it will tell you that there is some problem with the syntax, or some field is missing, or so on. And then the plan might be looking okay, but then there will be another issue when you apply it, because you don't know if everything is working unless you apply it. And we can only have testing. We can only have like quality if you have testing, and we can only test it on different environments. So that we will be reached in the last section. And if you are testing on non-production, you can call Terraform destroy, which will take everything which is in the Terraform state and delete it. So there will be nothing from that. Okay, so now it's this kind of boring part when you will be trying to connect from the GitHub Action or any other pipeline to the cloud. So there are 3 cloud providers in my slides, and Azure is the only exception where you need to define the environment variables to connect to the cloud, and then you need to define these variables to store the Terraform state in the Azure storage. You can live without the backend, but you will store the state somewhere different. In basic cases, you can test it locally. In more advanced cases where you have a lot of money, you can use the Terraform cloud, which will manage the state for you. So you don't need to take care of the state, because it will be taken by the Terraform cloud. But usually what I do, if I'm using one cloud, I'm using the same storage, the service of the storage for the Terraform state from the same cloud provider. So that's why I have it here. So the same goes for AWS. AWS, it has special action where you can just call AWS actions, configure AWS credentials, some version from the step by uses, and it will do it for you. You just need to pass some of these variables. And for S3, which is simple storage service of AWS, you just need S3. Then GCP is the Google Cloud provider, is the youngest one, not the youngest from the all cloud providers, from these big cloud providers. And it only actually needed the service account key, and that's it. You don't need the account email, project, and agent, but it's better if you have it, so at least you know where to go, whom to blame if there is a problem. And the Google Cloud Storage is just using bucket and prefix. Okay, so now we have configured the Terraform workflow in GitHub Action. We wrote all the kind of workflow files with the steps that I was describing here. And now let's take a look on the code structure of the hypothetical repository that we will have. So I choose this kind of best practice to show you how it can be done. It can be always done differently. That will be described on the strategy part. But you have three parts, which is environments, one directory, modules, second directory, and utils, which is kind of like help or I don't know, some optional scripts and stuff which doesn't belong in either two. And I have 4 environments here: dev, test, staging, production. And in all these files, I have backend, which is saying where the state file is, and which is the provider. I have the main TF, which contains all the kind of resource group, which are stored in the modules. And then I have like providers, which is if I'm using, which cloud am I using, or some third-party service, for example, PagerDuty, or you can have repository which will manage repositories in GitHub, because everything can be managed by Terraform. And the same is basically copy-pasted in all the other environments with only changes of some values. So there is a lot of copy-pasting, but it's kind of clean and you know what it does. The only problem is when you are looking for bugs, you need to compare all 4 and see which was missing and where, or which was added extra. So it's kind of painful for that. So environments are kind of separation of CD stages to preserve the quality of the code or just validate the quality with different ways. The production is the customer environment, and everything before is 1 degree further from the customer. And modules, they can group resources based on different logic or different kind of ideas. So I just listed logic provider component, but it's kind of more extensive topic when you will decide to learn Terraform. And that's about Terraform, and I'll discuss some like something which is unrelated to Terraform, but it's more related to the product or the company structure. Are there any questions about Terraform? This is kind of thinking slide about what is possible. And when I was starting to implement my first project in the GitHub using Terraform, I used this just for like testing. So I have single environment, and I was trying to make it multiple, not in a very fancy way, not using modules at all. But it's good start for learning. So don't forget about the basics. It may be like easy to try something. You can start your own project just to try something new separately from the big project before you make a change in the big project and everything stops working suddenly. So this is very useful and use it often, but then don't make it bigger. Just stay here. And then if you want to have multiple environments, then you can use either the structure I showed on the previous slide, or you can use something different. But what is more important is the kind of when and how it will be deployed. So the simplest one is you deploy one environment in the time, which I used in my case. Or you can use everything everywhere at once. This is very, very easy with the GitHub action, because you can use jobs, you can use matrix, and you can define which environments will be there, and it will run everything everywhere. And that's something which you don't want most of the time, but it can be useful to just have it for starter. Or you can have gradual deployment with manual testing. Just a kind of quick questions. Who preferred this over this? The 3rd row over the 4th row? Is there anybody? I would prefer this because I don't believe automated testing. Because I was working in many places, and there is nothing like 100% code coverage. So there is always better to have like kind of compromise between these two and gradual deployment. If you are deploying something with Kubernetes and it doesn't have many resources which can break things, I think you can go with that. But this is not the scope of this presentation. And the second problem is the code segregation, multiple repositories. There are two movements. One is called polyrepo, which is this, and there is another one which is called monorepo. Does anybody knows about these two? Raise your hand. Okay. So I prefer polyrepo to just have things separately and have small repositories, which is easy to maintain and replace in case. And there I'm just like putting three reasons how to kind of separate these repositories. You can have separate application code from the rest of things, which is mostly done when you have like developer teams, DevOps teams, and others. Then you have Terraform modules, which is your case, right? Then you have teams that are responsible for these repositories. And this is a problem. And the problem is when you start nesting the modules and you have version dependency, which I will follow on the next slide. And it's better to have modules which are kind of either industry standard, so it's maintained outside of the company and you're just reusing them because everyone does, or you have like option to opt out, so you can copy the module and use your own version of it. Then you can have separate repositories for GitHub Action workflows if you need to. Mostly companies have this because of the security reason, so they are not using the public GitHub Action workflows, they have local copy of them. It's for security, and it's also if the repository gets deleted by some reason, they can still operate. And the last topic today is versioning. And then it's the versioning orchestration. So I believe in semantic versioning because 3 is a good number. You can have some patch version or some comment after it. It's free. But mostly there are two types of changes: breaking change and unbreaking change, and some like bug fixing, or just a build number or something. I believe in using tags, so you can use tags for anything you want, but you need to have some process on it. And I believe in automatic tagging because it's really difficult if you need to go and manually tag something. It should be done automatically. And then there is a problem when you start using Terraform, GitHub Action, and everything, and you start growing, like big company, bigger project or something, you will get into something which is called dependency hell. Raise your hand if you know this term, dependency hell. Okay, good. And this slide is basically about it, because when you start separating stuff like here, and you start versioning them like here, you will have dependency, and you need to know which version or which component and which version is compatible with another component and another version. And there are kind of 3 approaches how you can do it. And usually the beginner's one is this one. So you start with using the latest, and you find out that it can easily break and stops working. Nobody knows why, and it can be also easily hacked. Then you switch to manual, and then if you find out better way, you switch to automated. But I have no information how to do it, just like describing the evolution of stuff. So that's it. Thank you for your attention. Do you have any questions? There's a question.
So do you recommend automating Terraform application, Terraform apply with GitHub Actions?
Yes, but not on production.
Right, so what's the human and the lead solution for production?
There should be some like approval. So you can have pull request, and if you have like at least 2 approvals, that might be safe, or you can have like automated actions just to validate more than I just mentioned. So you can run some tests somewhere, and you can either have green status or red status, and if it's red, you shouldn't allow to deploy it. Okay? Any other question? Okay, so that's everything. Thank you, and have a good evening.